to David. Welcome, David.
Thank you, Mary, and good day to everybody. We'll share my screen in just a bit. So my first point today here is to talk about what is Grasshopper, and I'm afraid to say that I don't really know the answer to that question. There's a lot of words that describe this sort of software, such as node-based editing or parametric design or visual programming, but none of these words actually really describe what it's about. So I think I'll just show you by example, and I will load a single screen. So I will show you one big file here, which is an example file which I just showed you, and then we'll close it, and then I'll show you 4 examples from scratch, and hopefully that'll explain what it's about. So the big file, which I'll load up from a disk, generates panels on a surface and measures the planarity of those panels internally. It's a reasonably complex piece of work here. You can see it on in the Grasshopper window. I have to zoom out just to see the whole thing. So when I zoom into 100%, you can see that there's a lot of stuff in here which I can tweak, such as sliders that change, for example, the number of panels on this surface in both directions. And I can change how these panels are scaled along the surface. If we wait for the screen to update, there we are. And eventually, once these panels are made, I can color based on their flatness. So I can even change the colors here in real time, and you can see the gradients run over the screen. And this example here even shows text on the screen. For each panel, it shows you the deviation from the planar area. So green is reasonably flat, and red is very, very unflat. We'll repeat some of these features here today in the examples, so I suggest we just get started. Before we do, I'd like to explain a little bit about the interface of Grasshopper itself. As you see, it's a separate window within Rhino, and it has separate files. So Rhino files are stored in 3D documents, and Grasshopper files are stored as HX files. And you will often have these files separately on the disk. And usually you have a Rhino file and a Grasshopper file which belong together. So always be sure to save from within this window. And you can open recent files from here. You can save documents as, it's all in there. The basic interface is we have a canvas in this area, which is where you build your networks. This is a freely accessible area where you can pan with the right mouse button. You can zoom in with the scroll wheel or control drag, just like in Rhino. You can select things, window select them. It should all be very familiar. Then up here we have the canvas toolbar, which is a bunch of useful tools for navigation and properties. And then up here we have all the tabs, which lists the categories for all the tools we have. So for example, we have categories for mathematical operations and vector operations, curves, intersections, transformations. So each tab has tools about one specific topic. Then within these tabs, you'll find the panels, which is like a sub group. For example, in curve, we can find analysis panel, division panel, primitives, splines, and so on and so forth. Also, as you see, the tools you see on the toolbar might be a subset of the tools available. So if you click on the black bar of a panel, you will see a list of all the tools that are actually inside that panel. Because if you change the window size, it has to hide more and more icons. So what you see on the screen is usually only a subset of what you actually have. Okay, the final bit here is in the right top in the menu. There is a drop-down list of all the documents which are currently open. So if you have more than one file loaded, you can switch between them using the top right menu item. And right now there's only one file loaded, so there's only one preview here. So let's start with the examples. I will explain what we'll try to achieve, and then I will do it step by step in Grasshopper itself. So the first example here is very, very simple. We'll start by making points and lines. And the goal here is to make an arc, which is defined by 2 points and an elevation. So we have 2 points. We'll call them A and B. And we use those 2 points to generate a line in between them. Once you have a line, you'll find the line midpoint and raise at that midpoint with a certain elevation. So this will be a number for a Z motion. This gives us 3 points, A, B, and this raised midpoint, which we can use to actually make a single arc through 3 points. So in Rhino itself, that's pretty easy. We can just if I do this in Rhino, I can use the point command to generate 2 points in world space, then run the line command to generate a line between those 2 points. So I can pick with a mouse, pick point A, move to point B. Once we have this line, I can make a new point using the mid snap. So I can switch on mid snap and try and pick a point in the middle of this line segment. We can select this point and move it upwards. So I can move it from 0, 0, 0 to 0, 0, 5, which will effectively raise the point by 5 units. So I can see it's actually above the line. And the last step here is to make an arc from start point through this raised point to the end point. So in Rhino, those are the steps, and I'm sure that you all know how this works. So let's start to try and do this now in Grasshopper itself. I can bring up the window, and the first step here is to take these points and reference them inside Grasshopper. For this we'll need a point parameter, and in the first tab, which is called params, which is short for parameters, you will find all the data types we support in Grasshopper. And they're in 2 different groups. There's primitives, such as numbers, integers, text, colors, and time, for example. And then there's geometry, such as points and vectors, and curves, surfaces, meshes, and so on and so forth. So we want to have a point parameter because we want to import the points from Rhino into Grasshopper. I can click on this point parameter here, and it will change my cursor. And I can click somewhere in the canvas to place a point parameter. But as you'll see, it's actually orange. And this is because it's a new parameter which doesn't have any data yet, so it's empty. And when a parameter is empty, it's pointless, and we treat it as a warning inside Grasshopper. When you put the mouse over the little balloon here, there will be a tooltip with the warning spelled out for you. And in this case, it said that floating parameter PT failed to collect data, which of course makes sense because it doesn't have any data yet. So to assign data, we can use the menu in this point parameter. So right-click on the parameter itself, and there is set one point inside this menu. And I can click on it, and it will then ask me to actually pick a point object. For example, I can select this one over here. And when I select it, there will be a red cross drawn over this point, indicating it's now being referenced by Grasshopper. And if I select this object over here, you'll see that the cross goes green, so we know which objects in the viewport belong to which objects on the canvas. So red or green, depending on the selected state. Let's do it again. I'll make a new point parameter, which I'll drag from the toolbar directly onto the canvas. Open a menu and set one point, and I'll pick the other point. So now we have 2 points referenced from Rhino into Grasshopper. The next step was to make a line between these 2 points. Now, if you don't know where to find the line component, you can search Grasshopper by double clicking somewhere on the canvas in an empty spot. So if I double click here, nothing happens. But if there's an empty spot like over here, I can get this search box. And I can search for the term line. As you'll see, there's quite a few components and parameters that actually use the word line. For example, here there is curved line intersections. There is planes from line and point. But we want to have a line from 2 points, which is one over here with the 2 points at the end. So I can click on this hit here, and it will make a new component for making lines. This is a bit more complicated than the point parameter before. This one has 2 inputs and an output, and there's all these letters on the screen as well. So we can use tooltips to figure out what this is all about. If I hover over the icon itself, it will tell me that this is a line component, and it's supposed to make a line between 2 points. There's an A input and a B input, and if I hover over these, it tells me it's a line start point for A, and B is the line end point, and the output here is a line segment. Now, that of course makes perfect sense. So to put these points into this line component, I can drag a wire from the output to the input, or from the input to the output. It works both directions. Once I make the connection, this component knows what to do, and it will generate this one line segment here on the screen. And the output will be filled with a single line segment, and it will even tell you the length of the line segment. Okay. This is already a very simple but working network that actually makes new information based on old information. In this case, it makes a new line based on existing points. And what we now have is more data. So we have just 2 points, but now we have 2 points and a line. And I would like to find a midpoint of this line segment here. We can do this in a number of ways, but the easiest one is to use a point-on-curve evaluator, which is a special component that exists in the Curve tab, first panel. It's called point-on-curve. And it's a bit of a special thing. It has a slider inside of it, so you can use it to actually get a point somewhere along a curve. I can share the line with this new object. Now, as I drag this value up and down, you'll see the point move along that line segment. So from 0 at the start to 1 at the end. Now, we'd like to be in the middle, so it's 0.5. And in fact, you can just go into the menu here and pick the midpoint to be sure it's exactly in the middle. So now we have already more data still. We have an extra point in our network. Once you have this point, we want to move it along the world Z direction, so move it straight up for a specific number of units. And I don't know how far. We can just hard code it for say 5. But we can also use a slider to control how far away we want this point to move. Sliders are in the parameter panel. It's a number slider. And this is an extremely useful control, because it allows you to define a single number, and you can change it on the fly just by dragging this thing left and right. So we want to use this slider, this number here, to move this point upwards. And well, first of all, I wanted to move further than 1 unit. So I'm going to change this slider to go not from 0 to 1, but from 0 to 10. In the menu, I can select the Edit item and change the slider to have a lower limit of 0 and an upper limit of 10. And now the slider will go from 0 all the way up to 10. Okay, now we have to combine this point, the green point, and move it this amount in a Z direction. Now moving works in the same way as Rhino, except instead of 2 points, a move from point and a move to point, you will define a move translation vector. So the move component has 2 inputs, geometry to move and a translation vector. And it outputs the moved geometry. Now, we want to move this point. And a vector is a straight-up vector. And I can just define a new vector from scratch if I want to. I can drag in a new vector parameter, open a menu, and